Okay, so let's dive into all this software engineering stuff you've been digging into. Blog posts, talks, even some code war. You're really after that secret recipe for becoming a software engineering master, huh?
Well, it's impressive the range you're covering. I mean, you've got everything from database deployments to making remote work, actually work. That says a lot about how you approach software engineering in general.
It's true, the small changes thing keeps coming up. Small pull requests, those atomic deployments, breaking down learning into bite-sized projects. It's everywhere.
There's a good reason for that. It's all about managing complexity, which is key in software development. By making tiny changes, you basically reduce the chances of bugs creeping in, and if something does go wrong, it's way easier to spot and fix.
Like building with Legos, right? One brick at a time. Nice and steady, not trying to slap the whole castle together in one go.
Perfect analogy. And you know what's really cool? This whole small changes idea, it goes way beyond just coding. It's the entire software development process from start to finish.
Now that you mention the bigger picture, I'm seeing a lot about stuff beyond the code itself. Communication, working with others, even personal branding, especially for those starting out. It's not just about being a coding machine, is it?
Not at all. Being a well-rounded engineer is so important. Explaining your ideas clearly, being a good collaborator, even knowing how to market yourself. Those are essential skills in today's tech world, no matter how good a coder you are.
Right, being able to explain your code is just as important as writing it in the first place. And speaking of getting things done, there's a bunch here about optimizing, especially with Redis caching. What's the deal with that?
Caching, it's super powerful for making things run faster, that's for sure. But your materials are spot on about avoiding premature optimization. Remember that quote. Premature optimization is the root of all evil. It's about finding that balance, optimizing where it truly counts, but not getting lost in trying to make things perfect before they even work.
Makes sense. Now, another thing that jumps out, Node.js tutorials, comparisons to PHP, best practices, it's everywhere. Is that your go-to?
It seems like it's a big part of your world, and for good reason. Node.js is known for speed and handling lots of users. It's a solid choice for everything from those tiny microservices to apps that need to work in real time. You're in good company.
And here's where it gets really interesting for me, that human element. In the middle of all this technical stuff, there's a big focus on work-life balance, especially remotely. Finding mentors, being a team player, it kind of breaks that stereotype of the lonely coder in the basement, you know?
Right. It shows that software engineering is, when you get down to it, a very human and collaborative thing. You're
Mhm.
making tools for people, with people.
All right, you ready to jump into some specifics that I found really cool, the stuff that made me go, wait a minute, that's awesome.
Let me with it.
Okay, first up, zero downtime deployments. This came up with databases and Docker. So imagine updating your app without any downtime for users.
The holy grail, right? It's huge in software deployment. Minimizing disruption for your users so they have a seamless experience. You're talking about systems so robust, they can be updated on the fly without anyone even noticing. That takes serious planning.
It's like changing the engine on a plane while it's still flying.
Oh,
Okay, next, the power of logging. Your material is like begging people to use it.
it's crazy how many overlook logging. Think of it as a black box for your application. It tells you exactly what's going on behind the scenes, which is super valuable for fixing bugs and understanding performance. It's like having a detective on your team to solve those weird software mysteries.
Speaking of mysteries, Docker is everywhere. And not just the basics. There's stuff here about multi-stage builds, even using it with Kubernetes.
Sounds like you're ready to dive into the deep end with Docker, huh? Multi-stage builds. Those are a game changer for making those Docker images smaller, faster, and more efficient. And then there's Kubernetes. It takes containerization to a whole new level. Like, imagine it as the conductor of your container orchestra, making sure your apps are running smoothly across all your servers.
And for anyone just starting out in software engineering, that advice about building real projects and putting them on GitHub Gold, learning the theory is one thing, but real world experience, that's where it's at.
I wish I had someone telling me that when I was starting out. It's the absolute best way to learn for real, and more importantly, to show potential employers what you can do. It's like, hey, I'm not all taught, look what I built.
So we've talked about small changes, but what about these feature flags you mentioned? What are those and why should someone care?
Oh, feature flags are like having a secret control panel for your app's features. They let you release code, but decide exactly when and who gets to see those features. Imagine testing new stuff with a small group of users before everyone gets it, or rolling back a feature instantly if it's causing problems.
So it's like a safety net for your code, right? That sounds super useful in the world of agile development where speed and flexibility are key.
Exactly. Feature flags let you move fast, test ideas in a live environment, and make changes easily, all while minimizing risks for your users.
Makes sense. Okay, another thing I saw that seems pretty important, this eventual consistency thing. Honestly, I'm a little fuzzy on that one. Can you break that down for me?
Sure. Eventual consistency usually comes up with distributed systems, especially databases. It means that when you update data in one part of the system, it might take a bit for those changes to show up everywhere else.
So it's not about everything updating instantly across the board.
Exactly.
Yeah.
Unlike traditional databases that need everything to be consistent right away, systems with eventual consistency are all about speed and resilience. Availability and partition tolerance come first, even if it means data consistency lags a tiny bit.
Availability, partition tolerance, those sound important, but can you give me a real-world example so I can really get it?
Okay, imagine a social media platform, kind of like the one you're using to listen to this right now. Millions of users. If someone updates their profile, it's more important for the system to stay online and responsive for everyone than to make sure everyone sees that update instantly. Right.
Right, that makes sense.
So eventual consistency lets the system prioritize a smooth experience for everyone, even with tons of users. It might take a few milliseconds, maybe even a second, for that profile update to show up everywhere, but all the other stuff keeps running smoothly in the meantime.
Ah, so it's about picking a seamless and responsive user experience, even in a big, complex system.
Got it.
Yeah.
Now, I am noticing this theme of building software that's, well, resilient.
Hmm.
It comes up a lot in your material error handling, retry mechanisms deployments, this idea of anticipating failures and designing systems that can handle them gracefully. Like building an unsinkable ship, but instead of lifeboats, it's all about your code.
You're picking up on something crucial. Building resilient software is about making sure your systems can weather any storm.
So how do you actually build that resilience into software? What are some key things you've learned? One common approach is using retry mechanisms for things like API calls or when you're talking to a database. So if a request fails, the system automatically tries again a set number of times before giving up.
Like if at first you don't succeed, try again, but make it automatic.
Exactly. Another critical thing is to design systems that are loosely coupled, with redundancy built in. That means avoiding single points of failure, so if one part has issues, the whole thing doesn't crash and burn.
It's like having a backup generator, but for your code.
Yeah.
Now, we've talked tech skills, best practices, but your material also dives into the human side of being a software engineer. What stands out there?
Big one, never stop learning and growing. Software development changes so fast. Your research stresses how important it is to stay updated, play with new tools, be ready to adapt to new ways of working.
So it's like being a lifelong student of code.
You got it. And of course, being a great team player is huge. Software development is rarely a solo mission. It takes collaboration, communication, and navigating different personalities. Your sources really emphasize empathy, active listening, and clear communication to build a really positive and productive team environment.
Teamwork makes the dream work, as they say. Speaking of teamwork, you mentioned Agile and Scrum a couple of times. Why are those relevant here?
Agile and Scrum are popular frameworks for managing software projects, and they're all about iterative development, close collaboration between developers and stakeholders, and a flexible approach that allows for changes and adjustments along the way. It's about embracing change and delivering value in increments, as opposed to a rigid waterfall approach where everything is planned out in advance.
So instead of a rigid plan, Agile and Scrum are more about adapting to the constantly changing landscape of software development.
Exactly. Transparency, accountability, and continuous improvement are key.
Now, there's also a bit about DevOps and automation.
Right, DevOps is all about bridging the gap between development and IT operations. It stresses automation, continuous integration and delivery, CI/CD, and close collaboration between the development and operations teams.
So streamlining the whole process from writing code to getting it in front of users.
Exactly, and that's where automation comes in.
Sure.
Automating tasks like testing, building, and deployment helps to reduce errors, speed up delivery times, and improve the overall quality of the software.
It's like having a well-oiled machine for software development, right?
Couldn't have said it better myself. And speaking of well-oiled machines, or maybe more like a team of specialized robots, let's talk microservices. You've got quite a bit on microservices, especially with Node.js. It seems like you're really interested in how to build scalable and maintainable systems using this approach.
Microservices, it's like a bunch of little robots, each with one specific job, all working together to accomplish something big, right?
You got it. In a microservices architecture, applications are divided into small, independent services that talk to each other over a network.
Hmm.
Each service has a specific job, and you can develop, deploy, and scale them independently of the others.
So you're breaking down a big application into smaller, more manageable pieces. What are the benefits of that?
Several, actually. Microservices make things more flexible and agile. Teams can develop and deploy new features more quickly and with less risk. They're also great for scalability because you can scale individual services up or down as needed. Plus, they improve fault isolation, so if one service has issues, it doesn't bring down the whole system.
Sounds great. But I imagine there are challenges too, right? Designing and managing a microservices architecture can't be a walk in the park.
You're right, it's not easy. One of the biggest challenges is managing the complexity that comes with distributed systems. With multiple services communicating over a network, there are more potential points of failure, and debugging can become more challenging.
So you're saying it's not a magic solution. You need a solid plan and a deep understanding of how distributed systems work.
Exactly. Now, another thing that pops up when you're building applications that need to be resilient and scalable is picking the right tools. You've been looking at various databases, message queues, caching solutions, each with its own pros and cons.
It's like a software engineer's toolbox. You need the right tool for the job.
You said it.
Yeah.
Your research mentions both relational databases like PostgreSQL and MySQL and NoSQL databases like MongoDB. Each database system has its own quirks, so choosing the right one really depends on your application's needs.
So you might use a relational database like PostgreSQL when you need strong data consistency and ACID properties, while a NoSQL database like MongoDB might be a better fit when scalability and flexibility are more important.
Exactly. And then there are message queues like RabbitMQ, which you often see in distributed systems to enable asynchronous communication between services. They help improve performance and reliability by letting services operate more independently.
It sounds like selecting the right tools is just as important as writing good code.
Absolutely. In fact, they often go hand in hand. The right tools make it easier to write good code, and well-written code can help you make the most of your tools.
It's about finding that synergy between your code, the tools, and the overall architecture. And speaking of synergy, we shouldn't forget those soft skills that are so important in software engineering.
Right. Having the technical chops is crucial, but your materials emphasize that soft skills are equally, if not more important, for long-term success in this field.
So it's not enough to just be a coding whiz. You got to be a team player, a good communicator, a problem solver.
You got it. Communication skills are essential, both written and verbal. Software engineers often need to explain complex technical stuff to people who aren't technical, write clear documentation, and collaborate effectively with colleagues and clients.
So you've got to be fluent in the languages of both humans and machines.
Well said. Your materials also highlight problem solving as a crucial skill. Software development really boils down to solving problems, whether it's optimizing a complex algorithm, squashing a bug, or designing a scalable system.
So it's not just knowing how to write code in a specific language. It's about being able to think critically, dissect problems, and come up with creative solutions.
Right. And that often means combining your technical knowledge with analytical skills and a good dose of creativity.
Creativity, that's not always the first thing people associate with software engineering. But it sounds like it's really important.
It really is. The best software engineers are the ones who not only solve problems, but do it in elegant, efficient, and innovative ways. They can think outside the box, challenge the status quo, and come up with new and better ways of doing things.
They're like the artists of the tech world. Now, before we wrap up this part of our deep dive, I wanted to loop back to something you mentioned, mentorship. Your material talks about it a lot, both for people just starting out and for experienced engineers. Why is mentorship so important in software development?
Mentorship is incredibly valuable in this field no matter where you are in your journey. It's about guidance, support, a fresh perspective.
So, greenhorn or seasoned pro, you can always learn something from someone else.
Absolutely. If you're new to all this, a good mentor is like having a guide in the vast wilderness of code. They can help you learn faster, provide encouragement and support, and offer insights based on their own experiences.
And for more experienced engineers out there, how does mentorship change?
It becomes more about having someone you trust to bounce ideas off of, to share your challenges and wins with, and to offer new perspectives.
Less about the technical how-to, more about navigating leadership, communication, career growth, that sort of thing.
Exactly. Mentorship helps you reflect on your own approach, identify growth areas, and develop those leadership and communication skills. And it's not just about having a mentor, it's also about being one. Giving back, paying it forward. Your materials emphasize building a culture of mentorship, both within teams and in the wider tech community.
Right, like that saying, each one teach one. Sharing knowledge, helping others level up, love it. Now, we've covered tons about the technical side, the team side, but something we haven't gotten into as much is ethics. I noticed some hints in your material about responsible development, data privacy, that kind of thing.
You're picking up on something really important. As software becomes more and more a part of our lives, thinking about the ethical implications is crucial. And you're clearly tuned into that, flagging those materials about data privacy and the potential for misuse.
With great power comes great responsibility, right?
Exactly. It's not enough to just build something that works. Software engineers have a responsibility to consider the impact of their work on individuals and society.
So what are some practical things developers can do to make sure they're building ethically? How can they bake that into their process every day?
First and foremost, stay informed. Know the laws, the regulations, the ethical guidelines relevant to your work. If you're dealing with user data, for example, you need to be on top of privacy laws like GDPR and CCPA.
So good code isn't enough. You also need to understand the real-world impact of that code.
Precisely. And don't be afraid to really think through the potential consequences, both good and bad, of the software you're creating. Have those tough conversations, challenge assumptions, speak up if something doesn't feel right.
Don't be afraid to rock the boat a little if it means doing the right thing. Now, speaking of things changing the game, AI. It feels like artificial intelligence is becoming the software engineer's new best friend. What do you think?
It's definitely changing the landscape. We're seeing AI tools that can automate things like code generation, testing, even bug detection. This has the potential to supercharge productivity and make our software better. It's exciting to see you exploring this.
So AI is not replacing software engineers, it's making them better.
Exactly. Augmenting their skills, not replacing them. But remember, AI is still young. It's too early to say exactly how it will reshape software engineering in the long run.
It's like the Wild West out there, right? Unpredictable, full of possibilities. Speaking of the future, you've also got some stuff here about emerging technologies that could really shake things up. Quantum computing, blockchain, the metaverse. It's like the future is being coded as we speak.
It's an exciting time to be in software, that's for sure. You've clearly got your finger on the pulse of what's next.
Yeah, quantum computing is mind-blowing. That kind of processing power could change everything, couldn't it?
It's wild to think about. Quantum computing could revolutionize fields like medicine, material science, and, of course, artificial intelligence. The possibilities are really endless.
It's like something straight out of Star Trek.
Yeah,
And then there's
they're-
blockchain. Yeah, it's big in the cryptocurrency world, but it sounds like it has way bigger implications.
Absolutely. The beauty of blockchain is that it's decentralized and tamper-proof. This has the potential to revolutionize industries like finance, supply chains, even healthcare, by making things more secure and transparent.
And we can't forget the metaverse. It's everywhere we look these days. You found some interesting material about the opportunities for software engineers to create totally new experiences in this digital world.
It's a whole new frontier. We're talking about everything from virtual reality games and simulations to collaborative workspaces and social platforms, things we haven't even imagined yet. Still early days, but the metaverse is definitely going to change how we live, work, and interact. And you're right, software engineers like you will be the architects of this new world.
So to wrap things up, is there one big idea, one key takeaway you'd want our listeners to remember, whether they're just starting out or they've been coding for years? What does it really take to thrive in the world of software engineering?
That's a great question. If I had to boil it down to one thing, it would be this: embrace lifelong learning and growth. The tech world moves so fast. To really thrive, you need to be adaptable, curious, always ready to learn something new.
Be a student of code for life. Push those boundaries, never settle.
Exactly. Whether it's diving into a new technology, going deeper with a language you already know, or even working on your people skills, that growth mindset is everything.
Love that. And one thing I've really picked up on throughout all these materials is your passion for software engineering. It's infectious.
It's more than just a job, isn't it? It's a creative outlet, a way to solve real-world problems to make a real impact.
It's about shaping the future, one line of code at a time. Now, before we wrap up completely, if you could give our listeners just one piece of advice, one golden nugget of wisdom, what would it be?
If there's one thing I've learned over the years, it's this. Never underestimate the power of community. Software engineering is rarely a solo sport. It thrives on the open exchange of ideas, shared knowledge, and a supportive community.
Finding your people, your tribe, those who get it, who share your passion for tech, that's so important.
Exactly. Online forums, open source projects, local meetups, even just connecting with colleagues and mentors, embrace the community aspect of this field. It will make you a better engineer and make the journey a whole lot more enjoyable.
Building the future of software together. Now, you've really dug deep into the world of e-commerce, and I'm curious to see what you've uncovered there. It's fascinating, the systems that power online shopping, isn't it?
It is. It's where technology meets business in a really intricate dance. I'm seeing you delve into the inner workings, those back-end systems like order management, inventory control, payment processing, the nuts and bolts of it all.
It's like trying to understand the inner workings of a watch. All those tiny gears moving perfectly to create the seamless online shopping experience.
And what's really sharp is how you're differentiating between the systems built for internal use and those customer-facing applications. You clearly understand that user experience goes way beyond just the website's storefront.
It's like an iceberg, right? The customer sees the tip, the website, the products, but underneath is this massive, complex system that makes it all happen.
And your materials show you get the unique challenges of building for both sides of that coin. Security, for example, is obviously critical for everything, but even more so for systems handling sensitive data like credit card numbers.
Absolutely. And speaking of user experience, or UX, I love how you're paying attention to the design of those internal products. They might not be as flashy as the customer-facing stuff, but they're the backbone of any e-commerce operation.
It's about finding that sweet spot, creating a great experience for the customer, and making sure the systems behind it all are robust, efficient, and easy to use for the people who rely on them every day.
Speaking of making things easy to use, let's talk about readem files. You've got some great stuff here about why a good readme is so much more than just a boring technical document.
Right. A readme is often the first impression, the first point of contact someone has with your project. Could be a potential user, a contributor, even potential employer. It's your chance to not just explain your project, but to get them excited about it, to make them care.
It's like the movie trailer for your code. Gotta be exciting.
Exactly. Being clear, concise, well-organized, that's key. Make it easy for people to quickly understand what your project is all about.
And never underestimate visuals. Diagrams, screenshots, even a GIF can make your readm so much more engaging and informative.
Totally. They break up the text, explain complex ideas visually, even show off your project's interface in a way words just can't.
It's about bringing that code to life. Okay, switching gears a bit. I'm noticing you're digging into when to go synchronous versus asynchronous, especially for processing data and handling requests.
It's a fundamental concept, especially in web development. Your research shows you understand the trade-offs. Synchronous processing might be simpler to code, but it can create bottlenecks, especially with tasks that take a while, like fetching data from a remote API.
Like everyone waiting in one long line at the grocery store.
Perfect example. Asynchronous processing, on the other hand, is like having multiple checkout lines open. Everything keeps moving, so the system as a whole is much more responsive and efficient.
Got it. So if you've got something that might take a while, like sending emails or dealing with a huge file, handle it asynchronously so the whole system doesn't grind to a halt.
Exactly. And you're already looking at different tools for this: message queues, background workers, event-driven architectures. You're thinking about how to build systems that can juggle lots of tasks without dropping the ball.
It's like being a master juggler, but with code instead of bowling pins. Now, let's talk productivity tools. You've got some great tips here for free software that can help developers stay organized and efficient.
The right tools are essential. And the great thing is, you don't need expensive software to up your game. There are fantastic free options out there to help you manage your time, track your progress, and collaborate more effectively.
It's like having a personal assistant for your coding workflow. What are some of your favorites? The ones that are saving your bacon these days.
Toggle Track is fantastic for time tracking. It helps you see where your time is actually going and figure out how to be more efficient. Plus, it's great for both solo work and team projects.
What gets measured gets managed, right? Plus, super helpful for billing if you ever do any freelancing.
Absolutely. Another lifesaver is Calendly. It makes scheduling meetings so much less painful. Just share your availability, and people can book slots that work for everyone.
No more epic email threads just to find a meeting time. What about for team collaboration and project management? Any favorites there?
Trello and Asana are both excellent, even their free plans. They give you this visual, intuitive way to organize tasks, see everyone's progress, and collaborate smoothly.
Like a virtual whiteboard for your project. Now, let's shift gears a bit to something super important, being a great team player in software development. Your material really emphasizes the qualities that make someone truly valuable in a team environment.
Building software is a team effort. It's about bringing people together with different skills, different perspectives to create something amazing. And that requires more than just technical skills. You need those interpersonal skills, those soft skills that make the team click.
So, what makes a great team player in software?
Communication is huge. Being able to explain those complex technical concepts to anyone, techie or not. Active listening, sharing ideas constructively, giving and receiving feedback gracefully, those are all crucial.
It's like being bilingual, right? Fluent in both human and computer.
Exactly. And being willing to help others, to share your knowledge, that goes a long way. Great team players mentor junior developers, they answer questions, they create a culture of continuous learning.
They lift everyone up. Now, for those just starting out, getting that first tech job can be a little intimidating. What advice did you find for navigating that process?
One thing that really stands out is building a strong portfolio. You need projects that showcase your skills, your passions.
Rock the walk, don't just talk the talk.
Exactly. GitHub is your friend here. Share your code, collaborate on open source projects, prove that you can build real-world stuff.
It's like a digital showcase for your coding skills. But it's not just about what you know, right? Your material also talks about who you know, the power of networking.
It's huge. Networking helps you build relationships, learn about opportunities you might not find otherwise, and it can really help you get your foot in the door.
It's not about schmoozing at conferences, though. It's about building genuine connections, finding people who get you, who share your love for technology.
You got it. It's about surrounding yourself with people who can offer guidance, support, mentorship as you're figuring out your path.
And speaking of figuring things out, you make it clear that the learning never really stops in software engineering, even once you land that dream job.
Never. The tech world is always changing. To keep up, you need to be a lifelong learner, always expanding your skills, taking on new challenges.
Always learning, always growing. I love it.
Absolutely. Take online courses, go to conferences, read industry blogs, or just play around with new tech in your spare time. What matters is that you never stop learning.
As we wrap up our deep dive, what really strikes me is your passion for software engineering. It's inspiring.
Software engineering is more than just a job. It's a creative outlet, a chance to solve problems that really matter, to make a real difference in the world.
It's about building the future, one line of code at a time. And to everyone listening, whether you're just starting your coding journey or you're a seasoned pro, remember this. Embrace the challenges, celebrate your victories, and never lose sight of that magic that comes from building something amazing.
And don't be afraid to ask questions. Find those mentors. Connect with the amazing community of software engineers out there. There's always something new to learn, someone new to learn from, and exciting challenges are always right around the corner.
Building the future together. Thanks for joining us on this deep dive, everyone. It really is. And it got me thinking about something else from your material, that whole idea of choosing the right approach for the job, especially when it comes to processing data and handling requests. You were looking at synchronous versus asynchronous approaches.
It's a classic software engineering dilemma. Your research shows you get the trade-offs. Synchronous is often easier to code, but it can create those bottlenecks, especially when you're doing something that takes time, like grabbing data from an API.
Yeah, it's like everyone's stuck in one checkout line at the grocery store.
Exactly. But with asynchronous processing, it's like having all the checkout lines open at once. Tasks are handled concurrently, so the system is way more responsive and efficient overall.
Makes sense. So if a task might take a while, like sending an email or processing a big file, go asynchronous so you don't slow everything down for the user.
Precisely. And you're digging into different tools for this. Message queues, background workers, event-driven architectures. You're thinking about building systems that can juggle multiple tasks at once, seamlessly.
It's like being a coding ninja and a master juggler. Now, you had some cool stuff in your research about software engineering productivity tools. Those free tools that help with organization and efficiency really stood out.
Having the right tools is essential, but the good news is you don't have to spend a fortune. Plenty of fantastic free options can help you manage your time, track your progress, and collaborate more effectively.
It's like having a whole team of digital assistants for your coding workflow. What are some of your favorites, the ones you use all the time?
I love Toggle Track for time tracking. Helps you see where your time is actually going so you can be more efficient. Great for individual use and when you're working on projects with others.
Right, you can't improve what you don't track. And it's a lifesaver for freelancers who need to track their hours for billing.
Totally. Another one I can't live without is Calendly. It makes scheduling meetings so much easier. No more back and forth emails just to find a time to meet. Just share your availability, and people can book slots that work for everyone.
So much better than those endless email chains. Any other must-haves for our toolbox?
For collaborating with your team and managing projects, Trello or Asana are both excellent, even their free plans. They give you a super visual way to organize tasks, track progress, and keep everyone on the same page.
It's like a digital whiteboard for your projects.
Right.
Okay, let's talk about another important aspect of being a software engineer, being a great team player. What are those qualities that make someone so valuable to a team?
Building awesome software really is a team effort. You need people with diverse skills, different ways of seeing things to build something truly great. And that means having those soft skills to create a truly positive and productive environment.
So what are those essential team player qualities in the world of software?
Clear, effective communication is number one. Being able to explain complex tech stuff to anyone, whether they're a tech whiz or not, active listening is key. Sharing your ideas constructively, giving and receiving feedback with grace.
You've got to speak human and computer, right?
Exactly. And of course, being willing to help out and share what you know, that's huge. Great team players are always happy to mentor others, answer questions, and build a culture of continuous learning.
Love that, lifting each other up. Now, for those just starting their journey, let's talk about landing that first tech job. It can be a bit daunting. Any tips from your research?
Building a solid portfolio is crucial. It's all about having projects that showcase your skills and what you're passionate about.
Show, don't tell, I like it.
Exactly. GitHub is the perfect platform for that. It's where you can show off your code, get involved in open source projects, and demonstrate your ability to build real-world things.
It's like a digital resume for your coding skills. But it's not just about skills, right? You also talked about networking.
Networking is so important. It's how you build relationships, hear about exciting job opportunities, and get your foot in the door.
But it's not about being a social butterfly at tech events. It's more about building genuine relationships with people who share your love for technology.
Yes, it's about connecting with people who can offer guidance, support, mentorship throughout your career. Surround yourself with those folks.
Absolutely. And you emphasize that the learning never really stops in software engineering, even after you've landed that dream job. Why is that continuous learning so important?
Because the tech world is like a moving target, always evolving. To stay ahead of the game, you have to be a lifelong learner, constantly pushing yourself, expanding your skills, embracing new challenges.
It's about that insatiable curiosity, that drive to keep learning and growing no matter what.
Exactly. Take online courses, go to conferences, read industry blogs, or just tinker with new tech in your free time. The key is to never stop learning.
Well said. As we wrap up this deep dive, I'm truly inspired by your passion for software engineering. It's contagious.
Software engineering is more than just a job. It's about creativity, solving real-world problems, making a difference, and that's something to be passionate about.
Building the future of software, one line of code at a time. And to everyone listening, no matter where you are on your journey, embrace the challenges, celebrate those victories, and never lose sight of the magic that comes from building something truly amazing.
Couldn't agree more. And don't be afraid to ask questions, find mentors who inspire you, and connect with the amazing community of software engineers out there. There's always more to learn, new people to connect with, and exciting new challenges waiting around every corner.
Building a brighter future together. Thanks for joining us for this incredible deep dive, everyone.